Very much for all the introduction here. So again, all right, let me get straight into the presentation here. And so essentially the title of the topic is the top 100 plus AI use cases across multiple verticals. So one of the questions people will ask is like, why did I pick that topic? And then the reason I picked that topic is precisely for this reason. See, we all know, I don't have to go into the investments that are going into AI, right? So they're exploding, and it's real. Lots of organizations are investing money into AI. So, but according to this Gartner report, and which I 100% agree with, is one of the biggest mistakes companies can make is implementing technology only for the sake of having the technology, but companies are doing it. Only 16% of organizations are focusing on pain points and defining use cases prior to AI deployment. And that is the surest way to fail. And I know this from practice. I'm a practitioner myself. We do a lot of consulting work. And one of the organizations that we consulted with last year, and then the CTO said, hey, and I want to kick the tires of AI. And and we asked him, okay, what use case? And he said, we don't know, we'll pick the use case, but we have some funding, so we need to go spend some money. But I want my organization and my people to be exposed to AI. So that is how organizations are starting. And unfortunately, that is not the right way. So instead, what we should be doing is, okay, fine. There are some early adopters. There are companies who have been investing into this for a while. And we know there are quite a few successful use cases as well. So why don't we take stock of, so what are the use cases or use case categories that are already invested, that companies have already invested? Can we take a look at them? Number one. So once we take a look at them, and the second one is, okay, which organizations try to map the use cases to the organization. So on this slide, what I'm showing you right now, if you look at the landscape of all the AI use cases, which particular functions, which particular categories are where they're more popular, they've been successful. So that is what we have done here, right? If you look at it, we know that customer experience and then customer service, we have seen chatbots and other things like that. So where a lot of use cases are out there. And the second one, I see the predictive analytics. That is the holy grail of AI, right? In terms of, if you look at the analytics landscape, right? So you have a descriptive, diagnostic, and predictive and prescriptive, and descriptive diagnostic analytics are in the past. The real value of AI is going to be in predictive and prescriptive analytics. So that's where lots of money has gone, lots of use cases are out there. So that we'll be talking about in the actual talk during the conference. So what I'm giving you right now is a preview of what's coming, okay? So, and then operations is another area, right? So whether you take energy or you can take even high performance computing, those are the areas where AI has proven to be successful in really delivering value. And customer service I already talked about, and fraud detection. This is another great area where there is a pattern recognition of AI, has been used and is being used for detecting, frauds. And then I'll talk about this in a second later on in the next slides, which bank, with a specific real use case that I spoke to, okay? Risk management applies in multiple industries. So finance is one that we know of, but the risk management can also be applied to other areas, like in a security aspect of it. How do you manage the risk using AI ML? And in the second column, you're seeing more pricing and promotion in terms of looking at the patterns of the pricing, and then the where there is more value. So that's also being used. Customer insights, again, you are seeing a customer experience, customer service, customer insight multiple times in the use case categories. It has proven to be very valuable, right? So we know the big, the Googles and Facebooks of the world, they have invested heavily into AI. And then, of course, and the reason is that their customer experience, customer insights is very valuable to them. Supply chain, we have seen in areas of supply chain, AI has proven to be very, very valuable. Human resources, and this is a little bit of a controversial issue in terms of how AI ML can be used in human resources. In some areas, it's definitely beneficial. Some areas, it is not so. There are ethical aspects of AI that come into picture, especially with respect to how you recruit the employees in those areas. So organizations need to be careful, but there are use cases there. Knowledge creation, research and development. So I've taken about 10 of the top use case categories. I'm not calling use cases, these are categories. And within each category, you have multiple use cases. Okay. So now what you'll also be seeing in the conference presentation is a mapping of the use cases to industries, right? Each industry has adopted AI in a different way. From what you are hearing, what you are seeing, what our research shows is that finance and healthcare are definitely leading from AI ML implementation. And manufacturing, retail, government are the other three verticals that I've picked to map these things. And then if you look at these use case categories that you see in column 1, and if you try to map them to the industries, so I'm showing where the top 3 or 4 use case categories that are adopted in each vertical is what you're seeing here. So if you look at finance, so we are showing predictive analytics, operations, fraud detection, risk management. It does not mean that customer service use cases are not being employed in finance. It is just the top 4 that are heavily invested in the finance. So that's what you're seeing here. And so we will dig more into it in the conference with respect to this mapping of the use case categories by industry. And so this is where I will take a couple of minutes to give you a deep dive that I'll be getting into in the conference presentation. So if I take healthcare, right? So we spoke to Samsung SDS, the VP of Artificial Intelligence there. So it's a real case where they have taken, and this happened in 2020, they have taken 70,000 X-rays, chest X-rays, by working with hospitals and doctors, and they analyzed the X-rays with respect to COVID diagnosis. They came up with a 95% accuracy within almost real time. And the reason this is very, very useful is because if you know about the COVID diagnosis test kits, not the X-rays, but other ways, it takes about a couple of days and same accuracy is 95% accuracy. So if a severely sick patient goes to the hospital, waiting for the 2 days to get the results out, could be life and death. Whereas with this artificial intelligence implementation, they're able to cut down the time. That's one example. Okay. And the second one is the DBS Bank. It's one of the major banks in the Asia Pacific area, and they have used the fraud, AI ML for fraud detection. And the cool thing about this use case is that if before AI ML, they had a rules-based system in place to figure out the patterns, but the rules-based systems are not accurate, and then lots of false positives is what those systems are generating. But now, by augmenting the rules-based system with the AML-based filtering system, they're able to become much smarter, much more intelligent in detecting the fraud. So that is a real use case that they're using. And then the last one that I'm going to mention just for today is the data security, a company called Deep Instinct. We know that malware, we may not know, but the malware, any new malware has a 90+% of code from earlier malware. So they can figure that out. But the remaining 10% is where, with the pattern recognition and continuous learning, these companies have been able to, get smarter and smarter in detecting the malware as well. So these are all the real life use cases of AML that are happening in the industry, in various different industries. Okay, so that is what you will hear from me much more in depth during the conference. All these use cases. This is just a sample that I gave you. And then the reason why you should also be thinking about attending the conference is that whoever registers for the conference, especially for my talk, and attends, will get free copies of these ebooks that, simple primer for AI. It's something that you can explain to your grandmother, kind of a language, and A to Z glossary of artificial intelligence terms. So that is what I will bring to the party if you attend those my session during the conference. So, Mr. Murthy, with that, I'm going to leave it up to you.
I yeah, I mean, he already shared my background. So for this talk, I am planning to cover more into computer vision. So a couple of my background. In my current company space, I've worked in different areas. Currently, I'm working in conversational AI. I'm working on the Eno chatbot that Capital One uses, where we are also using some of the CNN algorithms along with the state-of-the-art like BERT. But I've worked in some of the areas for document intelligence where I was working on to detect barcodes in a driving license, and that uses a lot of those object detections. And for some of the projects like deblurring of the barcodes, where I was using generative adversarial networks. Um, Previously in Ericsson, I was also working in computer vision space, where I was trying to figure out like how we can expand the 5G network space in US by figuring out where are those utility poles and street lights where we can go install some of the 5G devices. And even in NYU, I've been doing a lot of work in vision space, and the same in Hong Kong. So I just thought that I should come up with a tutorial or more like a workshop which goes into detail about convolutional neural networks, and not just on the perspective of um, just business use cases, which I will include as well in the part B of project demo, but also to include what the mathematics part of it. So after this talk, people will know like not just the matrix multiplication of a CNN, but actually maths on like how details everything is going on in a complete CNN end to end. And more or less discuss about what are the object detection techniques, what is difference between detection and localization, what is instance segmentation. And there are a lot of like recent work that's been done in detection and recognition and segmentation. For example, as I explained, one of my work was barcode detection. So the similar work that's going on is car and plate recognition these days. There's a lot of work going in instance segmentation in autonomous car. And I've been involved in one of the competition of AWS Deep Racer along with Capital One, where we were trying to build a reinforcement learning model to figure out if we can train an autonomous car on a virtual track. So I will be talking some of those algorithms more on the mathematics point of view and theoretical point of view, so that if someone goes ahead and sees the code, we'll be able to understand that this is what is actually happening behind the code. So that's some of those things I'll be discussing. Other than that, I'll be definitely discussing some of the activation functions that we use and why we are using particular activation functions. Along with that, I am also going to be like, as I explained it, explaining different types of detection tasks. For example, in one of my project, I used region proposal networks. So I'll be explaining what are these region proposal networks. There are different kind of state of the art called RCNN, faster RCNN, single shot detectors, YOLO. I'll be discussing the differences between them, what exactly and how it works, and some of the other algorithms called mask region proposals, CNNs, RCNNs. Then I'll be discussing some of the existing backend backbones that we use called VGG16, AlexNet, ResNet, and some of the differences on why we need one versus the another. So my talk would be heavily covering all that. And then along with that, I will be definitely covering a project demo, which is my actually NYU final year work, which was on automated detection of street level product displays. The idea of this project was there's a lot of marketing of tobacco that goes on overall in US and also in New York City. And a lot of these tobacco marketing, they uses point of sale advertising techniques. For example, in 7-Eleven Delhi, etc., they use some of those tobacco like advertisements, and then that's what being used to attract people to buy these products. And one of the project which was led by NYU and New York City mayor's office is to figure out that where are these tobacco advertisements there? Is there a link between these advertisements and the income area? Is it in the high income areas, low income areas? Is there any relation? Can we map out these detected advertisements on the New York City map? So I'll be discussing one of my project, and definitely would be discussing about New York City youth exposure of point of sale tobacco, of how we kind of used an object detection algorithm to figure out where are these tobacco advertisements in New York City, and then finally map them out on a New York City map to see what kind of areas they are there any school near any school communities area or not. So I'll be definitely covering some of those work here. And then again, I use fast RCNN, so I'll be discussing why I used this particular algorithm versus another in detail. And then some of the data sets that we used, I'll be discussing that. So that's going to be one of the practical work that I'll be discussing after I talk about some of the theory. And then finally, one work, part C, I'll be covering generative adversarial network. I've done some of the recent work in my own company in Capital One on deblurring of the barcodes, and also for generating some of the synthetic data we were using GANs. So I would like to discuss about how does GAN functions, and then basically discuss about different kind of loss functions that currently GAN has, min-max, what is Steen loss, what's the difference between them, and then talk about conditional generative networks, which are used a lot these days in kind of like making those data sets which involves like painting or which are basically conditioned on some label. So I'll be discussing all that. And then I want to discuss one of the state of the art called deblur GAN, and that's because I use one of these algorithm in my workspace. So deblur GAN helped me to kind of blur out the driving licenses images, like deblur out them so that we can easily detect the barcodes. And I wanted to discuss like what's the difference between this deblur GAN versus some other algorithms, and how we kind of used it and like trained it in our data sets. Some a brief story on that. So I'll be discussing details on it. So overall, my talk would be covering a lot of the theory part, and would be discussing some of the takeaway would be to know like a project demo and how that object detection was utilized, and kind of understand some of the new state of the art in GAN space, so that at the end of the day, people have an idea about like actual algorithms and the maths behind the computer vision techniques.
Are you done?
Yeah.
Okay. Thank you for a very quick, very elegant, eloquent summary. And you already have all the slides. Looks like it. You'll be preparing probably more, and you zip through, but you covered everything very well. Just a quick question on road signs. GAN could be used for road sign detection, etc. in a for a autonomous car and other kind of vehicles, autonomous trucks and other vehicles as well. Could you address anything? You may not have done directly on it. If you have done it, that's good. But you could give us your wisdom on the industry.
Yeah. So I mostly use GANs. I've seen GANs used in two major things. Is actually the data, like getting the data. The GAN has been super helpful in producing synthetic data, and also another like interesting use case that I saw in my case was where we were. So what we did, like when I used the deblur GAN, we were actually sorry for the distance. Yeah, we were actually kind of seeing that whether we, not to produce the synthetic data, but if we have those barcode signs, can we create, like, can we use something like a deblur GAN to create a clean data set versus a blurred data set, and then teach the algorithm to basically tell that, okay, this is a blurred algorithm, blurred data set, and this is a deblurred data set, and from there help in deblurring the barcodes. But as you pointed out, like if a GANs is being used for a lot of the detections, what I've seen in GANs, and that's also like variational encoders, autoencoder also come in place, that where like GANs are used a lot in precisely developing an entire data set, or precise, it picks up very easily the nuances of the pixels of the in an image, whereas a variational autoencoder kind of helps in really smoothing out an image. So GANs has been really used a lot where they want to like pick up the exact pixels of an image, reproduce some of the exact pixels of an image, kind of understand what is the extra noise, can we remove that extra noise. So GAN has been very useful in kind of understanding the small details in a particular image.
Thank you. Have you thought about applications in Homeland Security, airports, and so on. I'm just giving two examples, but you can extend it itself in the war, battlefield, etc.
Yeah, like even for our barcode detection work or even any of those detection work, yes, GANS has been used a lot. Currently in company, it's been heavily used in producing synthetic data. It is one of, because some of the reason is, when we work on driving licenses, when we work on some of the security data sets, the issue that comes up is that we don't want to directly use a customer's data set directly, right? So GAN has been super helpful, that if you can create a something similar kind of a data set, driving license data set or a credit card data set, can we create a fake data set using GAN? It's been super helpful because it's very risky to use actual customers' credit card data for training. It has a lot of risky information. So to avoid all that, GANs has been very useful to produce the synthetic data set these days. Yeah.
Any mischievous applications are being used for the with the GAN for those who are perpetrators, etc. Anything that you have come across?
You mean to say like for negative purposes?
Yeah.
I've been seeing that a lot also. Of course, lately GANs are being used a lot for, I can see some of those in identification for face kind of things. Yes.
Yeah.
I myself not dealt with all that. I mean, because the space I work in, we protect the customer data as you know, to the highest limit, and then that's why actually GAN come on board to basically produce a fake data, so that we don't work and we don't touch anything on the customer actual data set, the NPI data set. We don't use it at all like that, like for training purposes. So the whole pipeline, GANs come on help, like really on board to kind of figure out whether so that we can use synthetic data. And also even though I work in chatbot team, and then our expectation of the customer is that we do not really use any algorithm as it is. There's a lot of explanatory on board. So Capital One is a very you have to be very careful on what data set you use and why you're using, and explain everything. So that's a different thing. But yeah, I have heard that a lot in these days. I've been seeing online, but personally I have not like dealt with anything like that, because I work in a very different.
Thank you so much for having me. I'm very excited to share my work that I've done recently at Bill.com as chief data scientist here, using deep learning, using machine learning to help understand documents. So, today I'll give you a very brief primer, actually show some of the exciting results. And then in my talk, I'll go into the deep details about the model, the experimentation, the research that went into it, and then, kind of the thought process to take a project like this, which is a fairly substantial project, from, initiation all the way through now to serving our users and our customers at scale. So I'll go through, I have a few slides here. So I'll give a talk in a few weeks on going beyond OCR. OCR being optical character recognition, helps digitize images into text. So as an example, if you're familiar with self-driving car technology, you have an image that has maybe stop signs or yields or something, in the some sort of sign. Well, OCR will try to detect any character in that picture and digitize it. So create a string from it. So extract the characters for the word stop or yield, things like that, a speed limit. In our case, so we are a payments platform and cloud service provider to small to medium sized businesses, primarily in the United States. And we're not self-driving car technology, but we utilize a lot of this very similar tech to extract fields from the types of documents that we see. In our cases, mainly invoices, receipts, income statements, contracts, things like that. Our documents are varied, right? So I have a template here, but we see very different types of templates, faxes, sometimes a picture from a cell phone, right? So people will take a picture of a receipt and upload that. So we need, the challenging problem that we're trying to tackle was how can we extract the important key fields to make a payment from that document. And what we ended up doing is treating that document as an image. So if you treat it as an image and you use computer vision, and computer vision has had leaps of progress made through by deep learning using convolutional nets, RAS nets, all the various types of deep learning algorithms now. And if we combine it with a recurrence model, so an RNN, actually similar to the I saw in the last presentation in RCNN, in that kind of architecture, we end up having that full end-to-end solution to extract fields.
Just friendly suggestion, Doctor.
Sure.
Could you blow up the screen fully?
Oh, yes. Yes.
One of the attendees, our attendees are very smart and they're on top of a lot of things and
Sorry
point
about
to
that.
us.
Is that okay now?
It's still not. It's still not. But if you cannot immediately do it, don't worry, because people cannot read the small font when it is not shown on.
Let me try to fix this. I'll fix it. Give me one
You have to
second.
go to presentation mode, I guess, or you are showing directly from the screen or something like that. Is there a PowerPoint kind of slides? No.
Yes. Let me just share my full screen.
Yeah.
And then I will explode this and see if does that work better?
Not completely. It's okay.
Oh, still not. Okay. This is as big as I can make it.
It comes back to the same thing, though. It comes back to the same thing. Don't worry,
Okay.
right? We'll not spend too much time on that. Yeah.
Okay. Let me dive into, I guess I have a few minutes. I can dive into some of the results that we saw. So using our end-to-end deep learning solution, which is an image-based solution, we're able to extract key fields from documents, from invoices with a confidence. So confidence being a probability that the model essentially believes that the answer is correct. So it's for a lot of machine learning in this project as well, it's not just important that the prediction is correct, right? That's important, but also it's very important when the model can tell you if it's confident that the prediction is correct, right? And that comes from the probability from the score. So as an example, if you're doing classification and you get a probability of 0.99 that an image has a dog in it, then the model's really confident that there's a dog. But let's say the highest probability for that image is 0.4 or 0.2 or something. I mean, the model's not as confident. It still gives you what it thinks is in the image, but it's not as confident. So I'll dive into that in the talk, but the cool thing is the model is also telling us when it is confident in extracting the fields. And so we can surface those to our users, and we can omit or not show any for the documents that have a lower confidence in terms of extraction. And we utilize that for extracting off of multiple pages. So this is you can't really this probably you can't see too well. It's small font on purpose, but the point is here there's 5 pages, and we're able to extract the key fields regardless of what page they appear on. So we score every page independently, and we grab the highest confidence score per page. And that tells us that with one document that is multi-page, there's one set of fields. There's one amount field. There's one, who to pay. There's one due date for the whole document. So it makes it an invoice versus having multiple invoices per page. And so this is a method that we use to process multi-page invoices. Here's a particular example of a receipt. If if this was a conference done in person, everyone would be traveling and taking, receipts, collecting them, maybe using Expensify or some sort of expense management platform to get reimbursed at the end of the conference when you come back home. In this case, you take a photo of a receipt, but wouldn't it be great if you can actually extract the key fields from that picture? And so our models are capable in that realm as well. So it doesn't have to, this is kind of the evidence that the document doesn't have to be clean and like have a form, template formats or, rotated or whatever, even in these kinds of tricky situations and lighting and everything. And that's where deep learning really helps in the generalization and the image processing part of it, and that we still are able to extract the fields. And so here we have the amount and the invoice date. And then there's we have a method as well to tell us where on the document those fields are. So we process the full image and you get the extracted predictions. You can also then figure out what part of the image those fields come from by the sensitivity per localized area. And so I won't go into this, I'll go into this during the talk, but the idea being we have an algorithm, and when we go and see when the confidences has varied significantly from the baseline, then we have a location as well of where each field has come from. So as an example, and this is also kind of where the idea of going beyond OCR is on this particular document. Hopefully this is visible, but you can see the amount appearing in 2 places here on this doc. This is actually one of my personal Amex bills, but you can see the location of the amount field in 2 locations. This is coming from the model, so there's 2 areas that are sensitive. So in OCR, you generally are focused on one. You're trying to find the one area that a field is located in. A lot of times we see repetition. And so this is proof that the model is using the whole image and finding the prediction off of multiple areas in that image, not just one area, but can be multiple if it's repeated over that image. Cool. So very excited to present the full talk in a few weeks at this conference in artificial intelligence. And you can always find me on LinkedIn, and we are at Build.com, a company that I'm a chief data scientist for. I've been here for a number of years now. We are hiring fairly aggressively, actually, based in San Jose, so in Silicon Valley, in California. Varied amount of roles, for example, in terms of seniority. We go all the way from intern, junior level, and up through senior, principal, and and higher up than that. So if you're interested, feel free to chat with me and find me on LinkedIn or find or contact through the website here.